Alright, now we're going to look at using Ecotect to do an acoustical study. So I'm going to start this out by importing some geometry. I should say this is a puppet theater. If you're looking at this and you're not in my 498 Spring of 09 course, you may not understand what this is. But what this is supposed to be a puppet theater stage with a little hole. What we're going to be testing is the theory that adding more to this enclosure is going to improve acoustical performance in this little model. First thing I'm going to do is, if I go here to this ray and particle analysis, this is what I'm going to be using to test acoustics. And what it's going to be doing is scattering acoustical particles from a source. It's actually a lot like the way that the lighting analysis is executed, and so that's the reason why Ecotect is also has this capability, because it's set up to do this sort of thing. But what it does, it takes a source and it sort of like scatters particles and lets them bounce around, and that can be used to represent the behavior of sound. So the first thing I need to do is I need to create a source, and that's going to be generated by a point in space. So what I'm going to do is I'm going to just stick a point there. I want this point to be in a position where someone possibly using this puppet theater would have their head. So this is a informed analysis. I'm going to stick it there. So that's pretty much where people have to end up when they're doing this puppet theater stuff. So so I can now make sure that's selected. I'm going to call that my source. Everything else I'm going to tag as a reflector. That means Ecotect's will bounce particles off of there. So let's see. I'm going to do spherical random, and let's see. I'll do more or less the complete range of sound, just because that's what I'm going to simulate. I'm going to drop this down to something a little bit more reasonable. Let's say 100. And we don't need to do that many bounces. Maybe we only need to do like 8. Let's see. Let's see what that does. Alright. What's going on here, Ecotect? It's not letting any of this stuff get out. Alright, I paused it for a second because I just want to make sure that I wasn't seeing this the wrong way. But I think what I'm seeing here is if this thing was sitting out in a field of nothing, it's going to be pretty hard to expect sound to get past this object and actually reach anything out here, because it really has nothing to reflect. If it can kind of make it through this hole, but then from where would it go? So what I'm going to do is get rid of this. I'll get rid of this model and replace it with another model that I did here. So let's try the case 2. So case 2 I've added, I'm going to select all these things as reflectors. So case 2 I've added sort of like a something encasing my sound source, and we'll see what this does. So now you see I'm getting somewhere, so I actually have a fighting chance of getting some sound to project out of my box. So I can put more rays into my analysis here, but it's not really gonna, won't say more than really what we have here to talk about. So, so I'll take those out again. So again, the box helps. I think we can conclude that from the hypothesis that this condition needs fixing. So let's look at this for a minute. So I have a choice when I do this acoustical analysis of what to display. I can just show the rays, which makes a lot of sense for me. I can show the actual particles. What this does is it uses this color code to tell you what type of particle it is in terms of how it's interacting with the surfaces. If you're really interested in this process, you might look these up to see what they are. But again, I'm more or less interested in the rays. I can make an animation of this, and you can play around with this on your own. Doesn't seem like it isn't showing up the way that I expect. Okay, well anyway, this is a way to go about this. So just to kind of complete this process, I'm going to get rid of that model. We're going to look at another one. I try to do a few different things here. Alright, this case kind of makes a room out of the whole scenario. So I have my sound source again. I have this puppet theater, which is now in a box, and now I'm enclosing the audience a little bit. So oh man, hold on a second. There we go. So now you can see what happens is I'm actually starting to get some rays like bouncing back and in. So if I was actually smart about this, this is what I would be doing instead of deleting things. Instead of deleting things, it would actually be, did I delete my particle? Let's get rid of those again. There we go. I'm going to put my particle on its own zone. Again, these zones are like layers of my sound source. So this is what I'm going to do. I'm going to get rid of these things and start naming these cases so that we can follow them. So I can actually, I'll turn this one off and I'll bring that other one back just so that we can compare them. Because what I'm going to do is, there we go. So I can actually turn that one off so it's not a part of the analysis anymore, and I can sort of run this analysis again. This is what I want to do. I want to increase the number of bounces because I want to get a little bit more density here. Alright, so I can't get much better than just getting sound there, so I'm going to go to my other case, turn this one off. I'll do the same thing here. We'll see how much better we can do than this. So you can see that's with the same amount of sound, so it's much more sound density here. And I think what's happening is the sound is not escaping when it gets out here to these to the periphery here. It actually has something vertical to hit, so you can see that's a striking difference in performance. So I'm going to turn this off. Whoops. I'm going to turn this off and pull in another model here. This one I did, let's see, what's the difference between this? Let me turn off these rays and particles here. So now what you see here is that there's like a little, I don't know what that did. I have a little hole down here, so it's actually like a place for sound to get out that's in the bottom. And then I also have the back of this guy's shape now. So let's see what this does just for fun. make sure this is its own zone. We'll see how much better we can do. So again, that's what we had. Let's run this same test again. So you see the density is much more dense as a result of those changes. So there you have it. That would be the use of this process and just testing out some variations of models.